Okay, our first theorem for similar triangles is called the side-angle-side similarity theorem. And it says if an angle of one triangle is congruent to an angle of another triangle, the picture has marked for us angle A and angle D being congruent to one another. So we have one angle of a triangle congruent to another angle, a corresponding angle of another triangle, and the sides including those angles. So we have side AB corresponding to side DE and side AC corresponding to DF. So they're saying if I have this angle congruent to another angle in another triangle, then the sides that include those angles, if they are proportional to one another, then the triangles have to be similar. So you can see here that we've got AB and DE corresponding with one another. So AB over DE is going to equal AC over DF. So the given information will give us side, angle, side. The sides being proportional to one another, the angles being congruent. And that's what we have here, is we have side, angle, side. We want to prove now that the two triangles are similar to one another. You can see in the picture on the right, what we're going to do is we're going to draw this parallel line. Now it's not a mid-segment, but it is going to be a parallel line. It's an auxiliary line, and we know that we can draw lines parallel wherever we want. Well, this we're going to place in a very specific location. We want to place this parallel line so that triangle XDY is congruent to triangle BAC. So we don't just haphazardly put it anywhere. We're being very strategic about it so that angle 1 will correspond to angle B. They will be congruent. We'll have angle XYD corresponding to angle C. It will, of course, have to be congruent. But what we're going to do is we're going to get to the point where if we draw this parallel line and angle 1 is congruent to angle B, then we're going to be able to say that angle E is also congruent to angle B, and then we'll be able to prove that the two triangles are similar by angle similarity. Once we do that, we'll be able to use the side angle side similarity theorem here on out. So here's a plan for that proof that we're going to do. Matter of fact, let's just do it. Now that I've talked it out, see if you can come up with the steps and then compare your steps to my steps. Okay, so we talked about drawing this auxiliary line to prove that two triangles were congruent, and then we'll have corresponding angles are going to be congruent, which would lead us to say that angle E is congruent to angle B, and then we'll have two angles in one triangle congruent to two angles in another triangle. So let's see if you can come up with those reasons. Make sure you hit pause while you work out your thoughts, and then press play when you want to see the answers. Okay, we'll try this proof and see how it works. We've got our given information. Angle A is congruent to angle D. AB is to DE, which is equal to AC to DF. So we have that proportion there, that's given information. We drew XY so that XY was parallel to EF, and also DX was going to be congruent to AB. Just fix this right here. And that's just being able to draw an auxiliary line. We're going to prove that DX is congruent to AB in just a minute. Angle 1 is going to now be congruent to angle E by corresponding angles being congruent when you have two parallel lines cut by a transversal. Angle D will be congruent to itself. That's the reflexive property. So we have triangle DEF is similar to triangle DXY. That's the angle-angle similarity postulate, which now allows us to say that dx over dE is equal to dy over dF. That's corresponding sides of similar triangles are proportional. We already know that AB over DE is equal to AC over DF. That was given information. And now we know that DX over DE is equal to DY over DF. Therefore, AB is equal to DX and AC is equal to DY. We can say substitution, or we can say the transitive property. And now we have two triangles that are congruent to one another. Triangle ABC is congruent to triangle DXY by side angle side. Here's our side, and our angle. Triangle ABC is congruent to triangle DXY. A and D is going to be the angle between the two congruent sides. And now that these two triangles are congruent, we can substitute and say that triangle ABC is similar to triangle DEF. If triangle DEF is similar to triangle DXY, and triangle DXY is congruent to triangle ABC, then by the transitive property, triangle ABC must also be similar to triangle DEF. And we will never have to prove this theorem ever again. So we're thankful for that, and we're moving on. So our next theorem is the side-side-side similarity theorem. It says if two sides, or if the sides of two triangles are in proportion, then the triangles are similar. So not two sides, but if the sides, if all three sides. So I'm going to grab my highlighter here. If AB over DE is equal to AC over DF, which is equal to BC over EF, then the triangles must be similar. We're not going to prove this theorem, but it might come up in your homework. You would do very similar, I love using that word when we're talking about similar triangles. You'd use a similar process of drawing that auxiliary line XY and using those corresponding angles and congruent triangles. So now that we have these two theorems, we can use them to see if triangles are similar to one another. So can the information given in each part be used to prove that triangle RST is similar to triangle WZT? So what I do is I try and highlight with a straight line. I try and highlight the parts that are supposed to be similar. So the corresponding sides would be RS and WZ. And then we would have I am not drawing straight whatsoever. And then we would have RT and WT lining up with one another. So let's see if this given information allows us to say that these two triangles are similar. Angle R has to be congruent to angle W. Angle S has to be congruent to angle Z. Angle T has to be congruent to angle T. Now, angle T is angle RTS, and angle T on the right is angle WTZ. So those do need to be named with 3 letters. Now they're not giving us any information on angles, they're giving us the information on the sides. So the proportion is RS over WZ has to equal ST over ZT, which has to equal RT over WT. And I'm just looking at the similarity correspondence and going in order: RS over WZ, ST over ZT, and then RT over WT. They say RS is 18, ST is 15, RT is 10, WT is 6, and that doesn't go there. WT is underneath RT, ZT is 9, that's underneath the 15, and WZ is 10.8. So let's see this. Let's make sure. RSWZ. Yep, I for sure have written this correctly. So we're going to reduce each one of these fractions. Now 10.8 is an interesting fraction here. We've got 18 over 10.8. I think the easiest way to do this is probably using our calculators. So we'll use our calculator. I can definitely reduce this to 5/3. So 10 over 6 will reduce to 5/3. And 15/9 will also reduce to 5/3. 5/3 is exactly 1 2/3, which is 1.6 repeating. When I take 18 and I divide by 10.8, in my calculator, I get 1.6 repeating. Therefore, with all the sides being proportional, we have the side similarity theorem that says that triangle RST is indeed similar to triangle WZT. Let's try the next one. Angle 1 is congruent to angle 2. WZ equals over RS is equal to TZ over TS. So we have angle 1 is congruent to angle 2, but we would also need angle RTS being congruent to angle WTZ, and we would need angle RST being congruent to angle WZT. So we would need either two of these angles, or we would need one of these angles, which is already given, and the two sides, they're giving us WZ and RS. We would need RT and WT. And that is not what they are giving us. They're telling us, so these would be the two sides that would need to be proportional. RS over WZ, or WZ over RS would need to equal, if I do RS over WZ, I would need RT over WT so that I could do side angle side, similarity, or I would need to have WT over RT. Same proportion, just both are flipped upside down, both fractions. We've got RS and WZ, but we don't have the other included side. So they're giving us the opposite side, and that is not going to work. So no, we cannot prove that these triangles are similar. Okay, I'll let you try the last one. Go ahead and press pause, and when you're ready to see the answer, press play. Okay, so what we found is that angle RTS and angle WTZ are going to be congruent to each other because those two lines are perpendicular. It's going to create 90-degree angles, which are congruent to one another. So now we just need the sides that are included to be proportional. So we would have, let's see here, use a highlighter. So we would have ST and ZT, and then we would have RT and WT. They give us ST is 32, and they give us SZ, this little part right here, is 8. Well, if the whole thing is 32 and this little part on top is 8, that means ZT has to be 24. So I come over here and I plug that in. 32 over 24 is equal to 20 over 15. It's just given information. I reduce the fraction on the left to be 4/3. I've reduced 20 over 15 to be 4/3. Since they equal each other, the sides are proportional with one another. These sides are the included sides of the congruent angles. Therefore, triangle RTS is similar to triangle WTZ. And these are the types of problems that you'll have in your homework. Hopefully, you'll catch on. It might be a little challenging at first, but don't give up. Work hard, persevere, and bring back your questions tomorrow. Good luck.